So today I'm very happy to present how the data acquisition method for extracting the PBLH and mixing that from ERA5 and HYSPLIT. So my presentations will include three sections. The first one is extracting the PBLH data from ERA5. Second is extract the missing depth from HYSPLIT. And third section, if we got enough time, I will briefly compare the two data from the two data sets. So first, for the first section, I would like to talk about how to derive the PBLH value from the ERA5 data set. First, we can go to the CDS, which is the Climate Data Store web page. Later, I recommend to search for the ERA5 hourly single levels, and after we click search, we can find these two. We can see these two single level data sets. The only difference between these two data sets is one. The first data sets, they have the time series in the name. So this is how I select the data set. So the ERA5 hourly time series data is suitable for a single locations extract, as we can enter only the latitude and the longitude of the location, and the ERA5 will select the nearest grid point to the request location. Meanwhile, the ERA5 hourly data is more suitable for the spatial analysis, because we can enter the whole graphic area, and then we can get the data from all the grid cells within the request area. So in this example, I will only show about doing the example with the hourly time series data, so I can compare with the HYSPLIT data later. So we just click here to select the data set. Later, we will go into the overview tab, but just click the download tab. First, we can select. We can see all the available meteorological variables, and we can select what we need. So in this presentation, our required value is boundary layer height, and I already selected. Next, we can enter the locations. So in this example, I select the Yongnan stations as an example. There we can input the data range. So please keep in mind that this data range is in UTC. So for example, I want to extract the data from 2014 until 2024 in Korea time, but I have to input also the last day of 2013. Later, we should select the CSV format for easier data explorations, and just click accept the terms of use. And also, ERA5 data can also be downloaded using a code. We can click the down arrow in the API request to check the code. But in this example, I downloaded using the web page interface. After click submit the form, we will go back in. It is automatically go back into your request website. After waiting a few minutes, we can click download. And this is the CSV file get from the ERA5 website. If we look at the last two columns, it is longitude and latitude, but it was not the coordinate of the Yongnan station that we input in the earlier steps. Instead, it is the nearest ERA5 grid point that's been to our input location that automatically selected by ERA5. And also, one more thing we need to pay attention that is our meteorological data they did not provide any unique with it. So to check this, we can go back to the data set overview tab, and after we scroll down, we can find the main variables. We can find and check all the unit for all the the meteorological variables. So now I would like to present about how to extract the missing depth from the HYSPLIT. for HYSPLIT, the first step is to configure the mixing depth calculation and the output setting. So first I open the optional trajectory setting. From here we can select the mixing depth computation method. So for the backward trajectory, normally in our lab we use the NCEP reanalysis meteorological data. So this data set did not provide the direct PBLH value, and also they did not provide the TPA profile. So we cannot use the two options, which is use meteorological models and compute from the TPA profile. So the only two options we can use is from temperature profile and the modified Richardson number. So in this example, I select the from temperature profiles. And later, we have to, normally the backward trajectory output will do not include the mixing depth value. So we have to turn it on in the setting. You can follow, and I recommend to turn on only the mixing depth, because later I already write a Python code to extract it automatically, and it will affect our extraction later. Next, for the next step, I generate only 1 hour backward trajectory, because here I set the total write time to only -1 hour, and this is 1 hour is already enough because we only need the mixing depth value at the starting time of the backward trajectories. And also in the daily setting up, I also select the interval only for 1 hour. So this way we can get the hourly data for the mixing depth. So the next step we will extracting the mixing depth from the backward trajectory files. This is an example of one backward trajectory file. So as you can see here, this column is show age. So at the age equal to 0 is at the receptor side, and at the starting of the backward trajectory. And for that reason, for every backward trajectory file, we have to extract the first. We have to extract the value of the mixing depth at the row where the age is equal to 0. So because there are so many trajectory files, so doing this manually would take a lot of time, so I prepare a Python code to do this automatically. So I already write before running instructions, so you can later just check it and follow it. So briefly, you only need to change two things. First, you have to collect and put all of our trajectory file into one working folder, and then just copy the working folder and change the path in the code. Later, we already know that the trajectory file normally share a common prefix. So in this example, I said UN stands for unit site, and you also need to change to set this prefix in the code. So all of the trajectory file with this prefix will be extracted. They will extract the mixing depth of these files. So after clicking run, the one Excel file is automatically generated in the working folder that we already set. And here is the example of the output files with date time. It is still in UTC. We have to change it back to KST if we want it, with mixing that in meters and the source files for checking the data later. Professor, do we have enough time to back
Yes, going.
So I would like to briefly compare the data quality between ERA5 PBLH and the HYSPLIT mixing depth. So these are the key characteristics affecting the PBLH and mixing depth data quality. For both data sets, they all use the reanalysis meteorological data. But we have to look at the resolution. The resolution is very different. The ERA5 data has got the 0.25 times by 0.25 degree, but the HYSPLIT got a much more coarser resolutions, like 2.5 by 2.5 degree. Especially for a single point, the ERA5 use the nearest grid point to our request locations, and for the high split, they will interpolate the data for our requested locations from the NCEP grid, which is much more costly. So for this figure, it's compared the monthly PBLH pattern from ERA5 and high split at 4 sites: Hwasan, Sannam, Eunice, and Yongnam. So here, the high split show a very similar pattern at all 4 sites. It shows similar, but the actual value is different. So I think this is related to the coarser resolutions of the NCEP data grid. So in contrast, the ERA5 show more side-to-side differences. So I can see that although the Hwasan, Eunice, and Yongnam are represented by the same ERA5 grid, so they will share the same data, but the Sannam is located in another grid which is more inland, so they can show a different seasonal patterns. So I think this suggests that the final ERA5 resolutions may help capture the spatial variation between the nearby sites. This is the end of my presentations. Thank you for listening.